So hi everyone. Today I'm gonna talk about industrialized construction, but more specifically, digitalization in the context of industrialized construction. Okay. So as Dayana already said, my name is Beda. I reside in Santiago, Chile, but as some of you know, I'm actually in Porto Alegre, Brazil, and from UC-Chile. Yep. So today's plan, we're going to talk a little bit about me, a little bit about industrialized construction, and we're going to talk about what digitalization has to do with this. Okay, so we're going to discuss, more importantly, what are the needs and give you some examples of what can be done on the research side and also on the industrial side. And then we can talk about it. So, as you guys already know, my name is Beda Barcoquebas. I'm a civil engineer from Brazil. Well, I'm actually from Canada as well. I'd like to point this out. I'm a proud Canadian myself as well. So I do a master's degree and PhD in Canada, the University of Alberta, and those are some of my projects. I say that I have two hats. One as an engineer, as a construction engineer. I started my path in industrialized construction actually in the industry, doing social housing in Brazil with concrete-based systems. Then I moved to steel structures, heavy steel structures, light steel frame. When I moved to Canada, when I started working with modules. Sorry. And then I started working with modules, wood modules, wood panels, pretty much wood in general. Then I started working again in Brazil as a consultant, developing some products for social housing for our mid-rise buildings. And lately, I've been doing also bathroom parts. Yeah, and here those are some of the companies that I have the pleasure or had the pleasure to work with. On my academic hat, I actually I work on the belief that data and technology can actually improve our productivity. So basically what I want, what my motto is use data to improve processes, to improve physical processes. So I do a little bit of product development. My main expertise is actually simulation, Monte Carlo simulation, discrete event simulation. But I also do a lot of programming regarding BIM, automation of design tasks and procurement tasks using BIM, and also I do data mining with sensors collected on the factory to improve productivity at the factory using data. So why change? So a lot of my friends ask me, why do you want to change? Why do you want to shake things up with industrialized construction? I'm sitting, in a hotel now in Brazil, which wasn't anything here was industrialized as far as I know. So I always say that the construction industry, we have two problems. One is the productivity problem. So you guys already know that the construction industry is not as productive as other industries and etc. We all heard about a project that is under budget, over budget, that is delayed. It doesn't matter if it's infrastructure project or if it's refurnishing the bathroom of your mom. We always heard about construction projects that are overcost and delayed. And if that's an industry problem, I think it's not that big of a deal. It's a big deal, but it's not that big of a deal. But I think the construction industry, in which affects the society so much, this becomes a social problem. I'm not saying that we have. I'm not saying that we have problems, that we have housing problems because of the construction industry. I'm just saying that a big part of why we still have a social housing problem or infrastructure problem is partially because of the construction industry. So we need to get better, not only for ourselves, but also to serve society. So talking about industrialized construction, I'm not gonna do a lot of discussion on the definition of industrialized construction. I actually enjoy this definition, and when we can use it for the context of this class. And this is from the Housing Ministry of Chile, which says that industrialized construction is defined as the act of executing construction in an industrialized manner, generally in a plant or factory, integrating one or more elements in which all components are integrated into a global process of execution and assembly, mainly applied on assembly and finishing activities on site. So a few examples are bathroom pods, exterior walls, interior houses. But one thing that I like about this definition is that it's not really focused on the product, but in the process. And that's where things change. We improve the process, right? It doesn't matter on the material, and it doesn't matter so prefabrication, industrialization is often confused with prefabrication, and that's not necessarily the case, right? So you can industrialize your job site without needing a plant. You don't need necessarily to prefabricate everything in a plant, in a factory. You can industrialize your job site with some construction methods to increase efficiency in your job site. So that's why I think this definition is so powerful. But again, if you have a different definition, I'm okay with it. So modern methods of construction is a taxonomy that was um, it was asked by the Housing Ministry of UK. So they didn't develop this. This actually they hired a consulting company to do that, in which is a taxonomy. So in a way, what is a taxonomy? Is a way of putting different construction methods, industrialized construction methods into boxes. Right. So the first one, so we have 7 categories. The first one is modern methods of construction. 1, 3D structural systems. So pretty much boxes, right? Boxes, usually rectangular, but you can have different shapes. What matters that is three-dimensional and is structural. Then you have 2D structural systems, which are panels. So walls, floors, roofs, everything that is 2D really, you can actually put there as, in this box. Primary structure. So actually, this photo, I'm sorry, I have to update this, but we're talking about linear structural elements. So beams, columns, stairs. So, and this is actually really applied in industrial construction. Additive manufacturing or 3D printing is the fourth one that can be done on-site or off-site. It can be structural, non-structural. We have non-structural assemblies and sub-assemblies. So here, despite the first three, it's not about the geometry, it's about the structural usage. So everything that is non-structural. So if I have an exterior wall that is not structural, if I have a bathroom pod, I'm talking about an element which is in 2D and an element that is in 3D. But if it's non-structural, is a modern method of construction 5. And the MMC is traditional building production led to site labor reduction. So, for instance, instead of doing this on site at the final location of the pile, you can actually reinforce this assembly even on site. So you're not changing the construction method, you're just making it more efficient. So you can have piping kits You can have reinforcement rebars pre-assembled. You can have post-stressed concrete, and all of that. You don't need a factory to improve your performance and to industrialize a job site. And then you have an MC7, which is the technology side of it. To be honest with you, I'm not a particular fan of this category, but it's there. So it's basically robotics, laser scans. So it's pretty much technologies that support this industrialization. So what digitalization has to do with that, right? So in the context of industrialized construction, we have two things, two key main differences. So according to the Handbook of Construction Tolerances, for traditional reinforced concrete structure, for in a height over 25 meters, I have a tolerance of 75 millimeters, right? If it's inside, we're talking about 152 millimeters. If we're talking about a precast column, this tolerance goes from 76 millimeters to 25 millimeters. In a way, not in a way, actually, if I go to an industrialized construction method, my tolerance is reduced by a third. While something similar happens also in steel, right? So my tolerances are much more significantly reduced, which is tough to do, especially when I have an interface with on-site elements. So, for instance, my column can be prefabricated, but the foundation is done on site. So I really have to be careful here, not only to do a lower tolerance system, but also predicting how this reduced tolerance is going to be is going to play out when you go on site. When I have to assemble this precast column into a foundation that was done on site. And also there is the data management aspect. So you guys all know about them, all know about the life cycle of a project. But when it comes to fabrication, that's a different ballgame. So we're not in construction, we're not used to do fabrication models. We're used to do shop drawings, which, well, in the first place, follows a tolerance that is 3 times higher. And what happens is that every industrialized contractor have their own way of doing things. And that results in a lot of duplication of data because there is a lot of mistrust about if the information that people on site send it to you is actually correct. If the guys from MEP disciplines, they take into account the construction system that is done in the factory. And there is so that leads to a lot of duplication of data, a lot of inaccuracies of the data. And again, not a lot of people do fabrication models, do fabrication drawings for a living in the construction industry. So in a way, every company does their own thing, but nevertheless, they have a lot more common challenges that they would think. But that's another history. Yeah. So let's dive into some examples. So this is my city in Brazil, Recife. This hotel is actually done on site, or this structure is very complex. It's actually shaped like a sailboat, which is good for the architect, not so good for the engineers. Well, it's challenging for the engineers. And after the structure, the bathrooms are a very complex area of the hotel. So in this project, the decision was made to actually remove the risk of building 320 bathrooms on site with a really tight schedule and actually doing that at the factory. So basically what was done is that you have the structure of the building, the structure of the bathroom, the structure of the bathroom, the substructure, all installations, waterproofing, finishes, everything done in a factory that is around 3,000 kilometers away from its final destination. This bathroom was tested a couple of times in the factory, was placed into a truck, was driven 3,000 kilometers, was rigged by a crane and installed in its final destination. So those are the two prototypes that we've done. So they're being placed at its final destination, and everything that you see inside was actually done 3,000 kilometers away, right? So of course this is a 5-star hotel, but as you can see, the level of finishes, is very good. And this bathroom actually was installed after this bathroom. These two bathrooms, by the time they arrived at the site and they were placed, they were tested, and then was good for use, was around 5 hours. So 2 bathroom pods in 5 hours. And then they accepted the prototype, we started production, and then the other 318 pods, they were delivered in 4 months. So yeah, so 320 baths in 4 months. We have less than 2% material losses on site. According to the client, they had a reduction of 20% in schedule. And actually, I talked to the contractor, and I revised the quality check, and actually only 5% of those bathrooms they had defects on site after installation, which like 5% is something, but I'm pretty sure those are results that they're not easy to find, like to come by in traditional construction. And this is a photo of a final bedroom. And as you can see, the person that stays in this beautiful hotel with this beautiful view, the person is not going to have an idea that this bathroom was fabricated 3,000 kilometers away, and this wall was done on site. And this is by design, right? So in this particular project, the bathroom has to look like a traditional bathroom. So no one is not gonna know that this bathroom was fabricated outside the job site. A lot of people ask me what's the difference in design about a traditional construction and industrialized construction. The best way that I like to say that we have is difference is that is a structure that walks, right? So this bathroom here, right? If I do an industrialized construction bathroom, I have to comply with all the codes, that are applicable to traditional construction. No questions asked, right? So I have to comply with electrical codes, sanitary codes, fire protection, structural, everything. Yeah, you name it. At the same time, I have to account for torsions, that this bathroom is going to endure while being transported and rigged. So in a way, the structure of a prefabricated pod bathroom is actually stronger when a traditional construction, because a traditional construction you don't have those stresses, where in industrialized construction I have to account for all the transportation stresses. They are very different. Those are dynamic stresses. We only have static stresses in traditional construction. And that's why we use some other techniques such as finite element methods that is heavily applied in mechanical and aerospatial engineering, in which, we do some dynamic analysis and accounting that we have 320 bathroom pots. Every kilo of steel counts because I'm multiplying those things by 320, right? So I'm going to show you my city in Canada, right? So this is Equibel. Um, I was very happy, very fortunate to work in the first panelized building in my city. So what you can see here, this is a residential building. It's a four-story building. In Canada, we do a lot of wood construction up to 6 floors now. At that time, it was only four. That's what the code allowed, but now we can do up to six. And what you can see here is we're talking about 64 units, right? Where all the panels, all the floor, roof, and wall panels, they arrive, uh, they arrive prefabricated, right? With exterior finishes, windows, doors, insulation, right? And this is a time lapse of 25 days, 25 days. So the original schedule would account for 4 months, and we did it in 1 month, right? And some information about this. So those are 64 residential units. One thing that is important to note is that in Edmonton we have to do a mix of building or of apartments. So I need to have a certain percentage of one-bedroom apartments, two-bedroom apartments, and three-bedroom apartments. So because of this L-shaped configuration, we have 64 units, but also have 13 types of apartments, which is a challenge because, like, I loved in Brazil when we did like the same apartment and when we just mirror the building, and then we would do one or two types of buildings and then replicate these to a whole bunch. Here, that's not the case. Uh, but it's just a characteristic. This is just an aspect of construction in Edmonton. So we have around 25% reduction in schedule. We have a reduction of 20% in wood consumption, and we have 60% less waste in wood because for obvious reasons. Actually, we did it in a factory, so it's much easier. You don't have a lot of waste on site. And this factory is actually 50 kilometers away, so it's much closer to the job site than in Brazil. And one thing that was a big, like at that time, I worked for the construction company. Later, I ended up working with the contractor. But at that time, I was working pretty much on site, so I really didn't care about the fabrication. I care about the assembly. And one thing that we did was actually being 4D because we wanted to know at which stage we were so we could coordinate all the trades. And then I'm going to show a couple pictures of that afterwards. And we did coordination in BIM to make sure that all of the MEP systems they would fit right in, right? Because we have to do all of that later on site, right? And then you have some color coding here. We have some models here. We did some, so it was a fun project. It was a fun project to work on, right? And yeah, so this is it. So those are some pictures. So the first week we started on this lab. In Canada, we do the garage on the ground in reinforced concrete. And the reason why we were so eager to know where construction direction of the building would be is because we had to coordinate trades. So it doesn't matter if you do the structure really quick if the other trades don't come along. So we had to start construction doing the risers. So those are the main gas lines, and then we were doing all. So we have 16 units. So we have 16 plus two shafts, so 18 risers. So by the time we reach third floor, we can actually be ready to actually start building the risers and start walking into the units. So here you see some pictures. Here you have we did a coordination so we can pre-drill most of the stuff. Second week, we already had the gas lines and the piping. We had foam insulation. Canada, it's Edmonton specifically is a very cold climate. It's like minus 30 degrees, minus 40 degrees, and all of that. Third week, unfortunately we didn't got everything right, so we need to drill a couple more holes. Nothing is perfect. I'm sorry. And this is the checklist of each apartment to make sure that they're good to go. We started doing the ramp for the building, and this is the factory. So the factory is much more automated than in Brazil. So as you could see some pictures, the factory, you have a lot of manual intensive uh, on the roof. So those building on the roof that you have a lot of advantages, but you don't take advantage of further mechanization as you do here in this factory in Brazil, in Canada, I'm sorry, right? So, and again, what I was telling you about digitalization, we have here schedules, material inventory, we have B models, we have CNC files. So these machines, they're fed, they know what they're doing because of the CNC files, right? And all of that has to be precise, right? The procurement of materials has to be precise, right? So we have different challenges. And so from here to here, 50 kilometers later, we have this. So now I have a question for you guys. Let's get in there. So I would like to ask you to actually to fill the QR code and tell me which one do you think is the best? The bathroom pods, the prefabricated panels, or you don't know? So we have 3 out of 3. Okay, we have someone else. Okay. By the way, I'm not doing a test here. There's no right or wrong answer. I promise. I can promise you this. Okay, so we have a higher preference of bathroom pods. Oh, now we're tied. Okay, awesome. So someone would like to share why it selected the pods or the panels? What do you guys think? I'm sorry, are we allowed to have
Yes,
conversations during the
of
class?
course, of course, of course. Don't worry.
Awesome. So you guys, who would like to share like their opinion? No one? Okay, fair enough. So yeah, so actually, and that's just a personal opinion. I don't think there is necessarily a right or wrong answer to this. I think it's really project dependent. And in reality, a lot of people they expect, right? They expect when we talk about industrial construction, they expect this, right? Prefabrication, panels, giant models, a factory, robots, lasers, and all of that. But in reality, this is a much longer journey, right? Because this this right here costs a lot of money, right? This costs a lot of money. And you have a really high risk, right? So in reality, well, at least in my opinion, you shouldn't start shooting for the stars, like shooting for the stars right away. You start slow, begin doing prefabricating, improving something on site, then start prefabricating something, you know, and finds the sweet spot for you, because as you initialize more and more, you're going to increase your complexity. Yeah, that's a fact. That's not up for discussion. If you start including more elements, if you start adding more value, more scope to a prefabricated element, or to someone that you want to improve on site, you're going to have more elements to deal with. You're going to have different disciplines to deal with. You're going to have different aspects such as constructability, cost, performance. So that's going to add complexity, which complexity is not inherently bad, but needs to be justified, right? So that's why you have a lot of examples, exterior walls, modular construction, structural elements. But for instance, if I have high rise, it doesn't make sense actually to industrialize the structure, right? You can actually prefabricate the facades because it's tough, it's complicated to do facades. It's very complex, right? You can have a bathroom part, of steel, or if you're doing, some sort of precast, and you need to add place the concrete, you can actually, do concrete bathroom parts and leave the negative reinforcement, to be solidarized with the concrete pour. Or you can do the full build, the full module. It doesn't matter. It's what it matters is to you what fits your business, right? And that's what it matters really. That's why that's why there is no right or wrong answer to this, right? So now, now that we finished talking about industrial construction, how can we improve processes, in industrial construction using, yeah. So now we're gonna talk about BIM in the broader sense of digitalization. So I'm not gonna discuss with you guys BIM. I'm pretty sure that you guys have much better professors in this. You have Professor Fabiano, Professor Toledo, that can actually give you a much better lecture on BIM than me. But I'm going to use BIM here as a technology. Not necessarily as a methodology, but as a technology that can help revamp productivity in construction, take into account the specific context of industrialized construction. So now, some things that are very different. So for instance, in traditional project, I need to know how many doors I have. Here in modular construction, I need to know how many doors I have in each module. So I work with a company that they realize that because they do a lot of oil and gas projects, and the design is, uh, is very standardized. But so they spend a lot of time, 40% of the time, actually doing takeoff and doing imports for the cost systems. And we don't have actually, for instance, softwares that actually are specific for industrialized construction. So that's why I think we have a big opportunity here, actually, to develop new methods, to develop new frameworks on this. So we have a workflow here, which is what they do. And then the first thing is actually to locate. So they locate the elements according to the models in a manual way. Nothing wrong with that. Just takes time, and you can is error prone. You can make mistakes. So you have Revit. You guys all know this Revit. This is the quantity takeoff. Revit doesn't know that, for instance, this toilet belongs to module 1. We know this, but Revit doesn't. So basically, we have this blank parameter here, and I developed a plugin that actually locates all the elements according to their models. So now when I go back to the takeoff, I can actually identify each model, each element according to model. But this doesn't really work for me because estimators, they don't really care about BIM, but they do care about Excel. So basically what I have is that I use Excel as an interface, right? So I ask in Excel all the information that I need, and when I upload the Excel sheet into Revit, and Revit brings me back all the information that I need. So in a couple seconds, we're gonna see that I can identify, each element according to the model, according to the code into the ERP system, and all of that. And now I actually not only do imports for ERP systems, but also for, checklists. So they have this checklist, which is a takeoff according to each model. And they do this, that's what they do in Excel. And since everything is in Excel, I can do a macro and actually generate, for project with 7 modules, I'm going to need 7 lists, and now I can do, 7 lists automatically, right? So this improves a lot. Here I'm not talking about the tools, I'm talking about the workflow, right? The tools, they need to they're facilitators for the workflow that we're proposing. So here we measured around 30% of man hours reduced per project. We had a better improved communications, and we're considering a workflow specific for the IC environment. We actually applied the methodology, so I suggest you to go through this paper here, which is, this paper here, which is the methodology that applied exactly to measure the value of each activity, right? I think the key difference, the key contribution of this framework is because if you talk to anyone that does project design and construction, if you ask when something's going to get done, they're going to tell you it depends, because there are so many variables. So basically, in this paper, we applied a value stream map, a combination of value stream mapping and a Monte Carlo simulation exactly to account for this uncertainty and to evaluate whether the activities that are being performed, they actually add value or they don't add value to the process according to Lean principles. The second paper here is application of this framework in another factory, in which we got similar results in the first after 1 year. But then those guys, they did something very interesting. They decided to change. So basically, they decided to change their process according to the tools that we developed. And they actually managed to get a reduction of 92% on average, which for me, honestly, I didn't believe it. Didn't believe them, but when they showed it to me. But I think the most important thing is that they do a measurement about the deviation in the quality takeoff in 3 different projects, and we got an average higher precision of 12%, right? So I think this, in a way, I think if you have a higher precision in quantity takeoffs, I think this is actually more valuable than doing something faster, because now you know that the quantities that you're getting is exactly, they're closer to what you're actually going to perform. So you don't overbuy material, and you reduce the risk of not getting materials enough during production. With the same company, so this is post-bid, right? So in this company, we got some of the tools that we developed, but we decided to actually do something different. So this is now pre-bid. So the client doesn't know exactly what he wants. He knows he wants a building for a dining room for 500 people, 300 people. They do a lot of oil gas projects. And the issue is that the company doesn't really know if they're going to get the project or not. They have to provide, sometimes this or not even this, and they have to provide a solution. They have to propose a solution for bidding, and that doesn't mean that they're going to get it. So, depending on the market, if it's bad times, good times, or business as usual, for every 8 bids they participate, they award one, they get one. So that's the cost of doing business. So if I award one, I still have to pay for the effort of doing those other 7 bids, right? And they have a lot of codes to comply. They have electrical codes, safety codes, they have for emergency codes, which they have to comply. So they need to accommodate the customer clients. They have a big demand, so they participate in around 800 bids per year. There is a lot of uncertainty during the bidding process, and more importantly, they already have standardized solutions. So they already have an office model. They already have a model for 7 toilets, 4 showers, 7 showers, and all of that. And the issue is that when you do big projects, you have to change them. So, for instance, if I'm doing bathrooms for 500 workers, I actually have to connect this model here with a model here on top of it. So I have to remove one bathroom, one toilet, to make way for the other model, right? And I have to account for a minimum distance to the exterior door in case of fire hazards and all of that. So stuff, right? So they have 2 main challenges. They have to generate layout that accommodates client requirements, local codes, and the use of most pre-designed standardized solutions. So for that, we have an index of customization index, which we want to keep it as low as possible, because that means less changes in the original drawings. And they work with BIM without having to model. So they want to get all the information, not having the hassle of having to model a BIM model, which is fine. It's challenging, but that's what makes my work fun. So this is a workflow that we implemented with this company. So we're using a generative design platform called Rhino, which I think for me is a game changer. I really want to, that's my first experience with generative design, but I really want to continue down this path. And what it does is generate multiple solutions and evaluating the best solution, in this case, to reduce the construction costs and to reduce the customization index in each module. Once it decides what is the best solution, we generate some documentation in order to replicate this into Revit, so we can get the BIM model. So it's not that I'm in the background. It's not that I'm transferring through the CAD layout to Revit. I'm actually replicating this CAD layout into Revit with the preset solutions and modified solutions. And now I have all the quantity takeoff that I need according to modules and according to the ERP system and all of that. And then I do some other automation for tagging and etc. And then I get to create sheets, right? So at the end, I think the video is going to show. So the layout's pretty much what we wanted, right? So that was a fun project. We're actually finishing the master thesis of the student, and the company they reported around 60% of time reduction during those layouts, which is quite cool if you ask me. Well, I'm biased to talk about it, but actually it's a project that I'm very proud of, and I want to continue in this line. I really look forward continue working with generative design because I think is a new way of thinking construction. To finish, and then we can talk about something that actually is a company that Dayana and I were working with here in Chile, there in Chile because I'm in Brazil now, which has nothing to do with prefabrication. It's industrialized construction, but not prefabrication. So this is actually very common. This construction method is very common here in Brazil, in which we do concrete monolithic structures with aluminum formwork. And as you know, you have an entire building which is divided into phases, right? Sections in which you have section A1, A2, A3, and then they go back. And this is as you guys know, this is a 3-day cycle in which I pour concrete every day, and then I pour concrete on usually two apartments per day. So every day, between rebar, electrical, and formwork, I pour concrete and I get 2 apartments per day, right, with one set of formwork, which now in Brazil, I started working with this in 2011, but now in Brazil is pretty much the norm for affordable housing. It's a very cool system. It was the first system, so I'm actually a little bit passionate about it because it was the first system that I work with. But you have a lot of challenges because each piece here, you have a panel, you have this connection, but plus this connection, but plus this piece and this other piece. So that's a lot of information, a lot of data, that is required. And this company that Dayana and I were working with, along with Caroline, that some of you know, they fabricate those formworks and they rent these formworks along with a little bit of selling. So the issue that they had is that they do the manufacture, and they do the rental. So when they do the fabrication model for a client, they have to know how many pieces they have in stock, available in stock, right, for this project, and how all the pieces they have to fabricate. So this is pretty much this is actually hard. Like and this changes every day. So basically, they do a lot of documenting. They need to do a lot of database management, and that's actually something that we actually help them generating those reports according to the need of the project and what they had in stock at that moment. So we reduce significantly the duration of those. Exactly doing so these exports. So from what I understand, some projects that will take one day up to 3 days, depending on the project. Now it really doesn't matter how big the project is, but it takes around 1 hour to 2 hours. And that's actually something that I have to publish about it. I still didn't have time to publish about this, but that's quite interesting actually to work with as well. So to finish up, so we're talking about the structures and etc. But I would like to talk about MEP. So MEP, if you guys ever worked with any MEP, you guys know that there are a large number of elements, a lot of connections, very time consuming, and you have an elbow which is 90 degrees with 45 millimeters diameter and 90 millimeters diameter. So, and everything that you buy needs to go through a cost database, a ERP system, and each element has a code that is very time consuming to revise, is very error prone. You can actually a code like this, you can then realize that instead of 30 elbows with 90 millimeters, it's actually 20 elbows with 90 millimeters, 5 with 45 millimeters, and 3 with 100 millimeters, and then 2 with 45, right? So it's time consuming, zero prone, you have a lot of stuff to go through. So basically what we did was we applied natural language processing. So it's actually this is very old school. Now people are doing uh, generative artificial intelligence on this, but we decided to take a step back. We decided to apply a more simple approach, computing wise, right? Exactly to detect the information of different parameters. So find the information to the BIM model, match it with the ERP system, and then process uh, all this information that is pretty much written by humans, and identifying this. So in the BIM model, we found that the information that we need, for the description of those models, like, so I have here the description of an element, right? And we found that the BIM model, this information is spread out into 5 different parameters. So if we find those 5 different parameters for each element, right, apply an NLP algorithm to detect if there is a match, right? So if we find a match of what we have in the BIM model with the description of this element, then we can get this code and assign it back to the BIM model. So this way um, when we do all the takeoffs, all the automated takeoffs, we can actually have everything that we need to import into the ERP system right away. So to wrap up, I'm sorry, I spoke too much, but I think I would like to finish this presentation just showing you that in industrialized construction, you have a lot of things to do. It's a great place to innovate. So in case you guys, please ask me as many questions as you want, and you have my email below in case you have even further questions.